Hello viewers, in today's class we are going to solve one important definite integral, right? So let us start. So here we have to find the value of this definite integral from 0 to pi by 4 tan x over 3 plus 2 tan square x, right? So let us start. Now here first of all we'll make use of the result that tan x is equal to sin x over cos x, right? So we'll substitute here uh, tan x is equal to sin x over cos x, and in the denominator we have sin square x over cos square x, right? Now we can simplify this expression, and we'll have sin x over cos x, and here we'll take the LCM. So here we have 3 cos square x plus 2 sin square x divided by cos square x, right? Now we can take this cos square x to the numerator. So we have sin x over cos x times cos square x over 3 cos square x plus 2 sin square x, right? So now cos x and 1 power get cancelled, so we are now left with 0 to pi by 4, and we have sin x, and here we have 1 cos x and dx, and in the denominator we have 3 cos square x plus 2 sin square x, right? Now see, here we have the combination of sin x and cos x, right? So what we will do, will in the denominator, what we will do, we'll take cos square x is equal to 1 minus sin square x, right? So here we'll substitute 1 minus sin square x. So now this integral I becomes 0 to pi by 4, and we have sin x cos x dx over 3 times 1 minus sin square x plus 2 sin square x, right? Now I is equal to 0 to 4 sin x cos x dx divided by 3 ones are 3, and then we have 3 sin square x, so minus 3 sin square x plus 2 sin square x is minus sin square x, right? So once we have obtained this expression, now we can use the method of substitution, right? So we have simplified the integrand as this, and now we can take t is equal to 3 minus sin square x, right? So when t is 3 minus sin square x, so dt over dx is equal to minus 2 sin x cos x. So this implies dt over minus 2 is equal to sin x cos x and dx, right? So for this sin x cos x dx, we can write dt over minus 2, right? So since we are changing the variable from x to t, so we should accordingly change the limits. So here we have x is equal to 0, here we have x equal to pi by 4. So when x is 0, then we have t is equal to 3 minus sin square 0. So 3 minus 0 square, that is 3, because sin 0 is 0. And when x is pi by 4, then t is 3 minus sin square pi by 4, and sin pi by 4 is 1 over root 2. So this is a square, so we have 3 minus half, that is 6 minus 1 over 2, that is 5 over 2, right? So when x changes from 0 to pi by 4, then t changes from 3 to 5 by 2. So now this integral it becomes equal to 3 to 5 over 2, and we have minus dt over 2, and 3 minus sine square x is equal to t, right? Because for sine x cos x dx we have dt over minus dt over 2, and for 3 minus sine square x we have t, right? Now this has reduced to a simple integral, because we can write it like this: 3 to 5 over 2 dt over t, right? So now the integral of 1 over t is simply log of t, and the limits are from 3 to 5 by 2. Now we can substitute the limits and we will take the difference, right? So first we'll take 5 by 2, and then we'll take 3. So we have log 5 over 2 minus log 3, right? So now this is half, it is minus half, and by the property of log we know that log m minus log n is equal to log m over n, right? So here we can write log 5 over 2 divided by 3. So now this is minus half log 5 over 6, right? So this is minus half log 5 over 6. So this is the required value of this integral.